Hello everybody and welcome to this new video. Today we'll be continuing building a calculator, and this time I will introduce a new concept, that being how to multiply to binary, how to multiply with a calculator in Minecraft. You could do this with just a adder, but that would take a very long time. So I'll teach you how to build a different component that is designed to quickly multiply different numbers. But because this is an entirely new concept, just like the time that I learned you how to build a adder, I'll first go into Paint because that's a lot easier to explain. First, I'll just use the decimal system like this to give an example for people that don't know how to do arithmetic this way. So, if you remember with multiplying, if you just the one number is just one digit long, it's quite easy. You just take that digit, multiply it by the first one. 3 times 2 is 6. And then you take it again and multiply it by the second one. 3 times 1 is 3, and 12 times 3 is indeed 36. That's a very easy example. Wait, why isn't this working? Oh, yeah, like this. But it's a little bit more complicated if your second number is more than one digit, longer than one digit. So let's take 13. I actually haven't tested out what the correct answer is for this, so I'll just do it with my real calculator in a second to check. The previous one you could just do in your head. I don't think many people can do this one in their head. But first you do it exactly the same. So 3 times 5 is 15. 5, and you carry the 1. 3 times 4 is 12, and you add 1, so that's 13. 3 times 1 is 3, add 1, and that's 4. Then you get to the second row, and then you'll begin again beneath the number you already have, but you'll start with placing a 0 over here, and then you do 1 times 5 is 5, and then you place 5 over here, so this number will be one digit more to the left. 1 times 4 is 4, and because this is just 1, you can just copy this number in fact. So that's 1450, and then you add these two numbers together. 5 plus 1 is 5. Oh, 5, sorry. 3 and 5 is 8. 4 and 4 is again 8, and then that's just a 1. I'll quickly check this. 145 times 13, and that is correct. You can check for yourself if you want to. Of course, we'll be working with binary. So let's get a truth table. What happens when you when you multiply different numbers? So you have input A. Let's give myself a little bit more space. Input B and the output. So what happens if you have 0 and 0, 1 and 0? Yeah, 0 and 1 is just the same, but let's do it for completeness, and 1 and 1. 0 times 0 is just 0. 1 times 0 is also 0. So 0 times 1 will also be 0, and 1 times 1 is 1. So, does this remind you of a gate? It should. This is the AND gate. I don't think I'll have space in there, so let's just write it above. This is a AND gate. So if you want to multiply two numbers together in binary, you just use an AND gate. Of course, that's only when it is 1 bit. when it's multiple bits, that's a little bit more complicated. Let's first try it with just with the second number is just 1 bit, so let's do 3, that's 3 times 1, and let's also do it times 0. Those are the only two possible combinations with just 1 digit as your second number. Because this is a 1, you can just copy it, so that's 1, 1, again 3. And because this is 0, whatever you multiply by 0, that's still going to be 0, so that will just be 0. That's not really interesting. Let's do it more numbers. Let's take 3 bits as seconds and 2 digits, 3 digits as the first and 2 digits as the second. Okay, so this is 0, so that will just be 0. Let's write 3 times 0. And then we write 0 here. And this is 1, so you just can copy it. And then we add those together. This is just 0, so something plus 0 will still be that something. So we just can copy this second number. And this is 5 times this is 2. Here you have 1, 2, 4, 8. 8 plus 2 is indeed 10. So this is correct. Yeah, if you don't know this, this is the method for reading binary numbers. If you don't remember this technique, go back to the second episode of how to build a redstone computer. But I think we're ready now to build this actually in Minecraft. So let's go. Okay, as you see, I have already constructed the input, pasted it in place. But anyway, you may see that this is quite long and this is really short. Well, this is 8 bits in total, 2 times 4 bits, and this is only 5 bits. Why? Well, this is one of the inputs, this will be the second digit, and this will be the first digit, and that is 3 bits long. Why am I choosing only so few bits? Well, the second digit is quite easy. If you go up to 3 bits, in the adding, you will have 3 different numbers. And then it's getting quite annoying to either construct multiple such things or loop them back around. It's just way easier to do this. And if you want me to explain how to do it, leave it down in the comments below. But for now, I'll just be sticking to these two. And these three, well, with just a number with 2 bits multiplying with a number with 3 bits, that's 3 times 7 max, and you can already get up to 21, and that's higher than the number display unit can represent, so there isn't really any reason to go bigger. It's not that hard to make this one bigger, but it's quite a lot harder to make this bigger, so just that you know that. Anyway, what will I be doing? First, I'll take this line, so these 3 bits, and make them 2 lines, like I did over here. Split them up, because if you remember, we need them 2 times. Once to multiply it with this bit, and multiply it with this bit. Then I'll end it, 1 time with this bit and 1 time with that bit, and if I'm done with that, I'll come back to you. Okay, I'm done. That didn't take very long. So, like you see, we have 2 sets of 3 bits numbers right now. So this one is AND gate. Is that a word? I don't think so. Doesn't matter. It's AND gated with the least significant bit. So the bit that is the most right if you read it. That's also quite important if you're making a calculator or a computer in general, to know how you need to read your numbers. Like if you want to read this number, you need to look at this way. Then if you orient it, then you see that this line becomes this line. So here this line is the most left. Here it also needs the most left. So this one you need to read like this. And here this is the most right. So this is the most right. So here you need to read it like this. And the most right number is the least significant number, is the smallest number. So this goes with this one. So this will be the small. This will be annotated multiplied with the smallest number. I mean the least significant number. I'm sorry. Anyway, now we just need to add those. But remember, the second one, you need to shift one to the left. So it's important that you link them right up. These ones you can just of course do them normally. Of course, here for this one we have 4 sets of adders and also 4-bit long numbers. Here we only have 3-bit long numbers, but we still need 4 adders because this one will use this adder, and this adder, and because it's only 3 bits long, it won't use this adder. But this one, oh, whoops, needs to be shifted to the left a little bit, so it won't use this one, but it will use this one, and this one. Of course, you can just run them straight through because you don't have to add anything, because I mean that the other output will always be 0, so it won't change anything. But I'll just like to do it because it looks better, and also if you want to expand it like in this side, you already have this added built. But if you want to, you can just ignore it and run the line straight through. So I'll copy this one into here quickly, and I'll come back to link them manually up so you can see what I'm doing. Okay, let's go. Okay, so I pasted it in and already relayed some wires. I'll show you why that is in a bit, but first let's connect these up. So I'll be using the least significant one for the bottom ones and the most significant one, that's this one, for the upper ones. You can switch that if you would like to. But okay, and then this one is for over here. I'm not doing it really pretty now, I'm just trying to do it fast so you guys don't have to wait. Okay, and then this one. And of course, now we ran out of lines from the least significant number, and that's right because here the next number already starts, and this one needs to stay empty. So now we do this one, and this one only starts over here. Okay, I can see that it's not reaching that. Also here, so I need to put a repeater there as well. Is that, nope, it's one off. Quite annoying, but can't do anything about it. Or at least not anything that's worth the effort. Okay, and last one, let's do it like this. This one already connects, and that one does as well. So, now it's all done, and you see how it adds. And I think, I'm not sure, I'll check in a bit. Wait, I can just check now. So this is 1 plus 0, that's 1. That's 1 plus 1, carry the 1, so that's 0, and this line should be 1. That's 1 plus 1 plus 1, so that's 1, and carry the 1. Okay, carry the 1, and this is just 1. 1 and 1 is 0, 1, so this would be 0, and we should have an overflow. So this is already an overflow, because here because all the lines are on, we're multiplying 3 times 7, and that's already too big to handle. This adder can only handle 50 numbers. Of course, you can't just take this output and make this bigger and run it into the number display units. That's no problem at all. But why did I uh, redirect this line? Well, now we have two outputs from different components, and if we let these outputs both run into the number display unit, it can cause some problems because it's overlapping. So what we need to do is have a system that you can control which of the two components is running true. I see that. I'll do that in a bit. So what we'll do is build a special component, and it's actually not a special component. It's actually just a just an AND gate, but a different way to do it. And why I don't do build like that one is because it keeps a clear difference if I use this one and I use that one. That one is more for adding and just really using it for the AND gate. But this one, I'll have to start a little bit back. This one, I see more as if this line, the other line, the input line is on, then it's letting this line through. But if that input line that I'll build in a bit is not on, then it doesn't go through, and the output just stays 0. So, and this I may not have enough space. I think I don't. No, I don't. I'll fix that in a bit. So anyway, we just start with 2 NOT gates. But for the moment, that doesn't change anything, because 2 NOT gates just cancel each other out, and that's not really useful. But here's a twist. There will be a line over top with redstone torches. But of course also this line to control the redstone torches. So what happens if this line is off, so this is the line that controls if the input will go through, well, the redstone torches go on, powering this line. So these two lines both power these lines. And if this line is powered, because it still needs to be inverted, this line will always go off. But if this line is on, this redstone torch goes off, and it doesn't interfere with the line, and it just can do its normal thing and 2 times, so nothing happens. Like if in this case this is already off, so no matter what, this will always be off, because 2 AND gates, 2 NOT gates will, like I said, cancel each other out, and it will always be off. But for a better example, I'll build it again, but over here. Okay, this one. So for the moment, this line, and again this is the line that, how I see it is, this controls if the input is going through or not. So if it just stays 0. In this case, it's off. So although this redstone torch is off, this line is still powered, and this redstone torch goes off. But if we power this line, the control line. This redstone torch goes on, and it's just letting this line do its thing. So it inverts, it goes to 0, and it inverts again, it's phase to 1, and nothing happens. You might see that this is exactly the same like this one, just built differently, but it helps me distinguish between the two different things. So what I'll now do is also build it for this one, and I'll redirect it a little bit, maybe move that one to move this whole component to over there. Of course with rollers, not block by block rebuilding, that would be a lot of work. Then I'll connect the two lines up, and then you have two control lines. And I'll also connect the control lines to write bits into the multiplier. And then it's actually done. So I'll get to it. Okay, the multiplier part is done, and I will admit this is a mess. If you make this calculator, please plan out where everything's gonna go, otherwise you end up with something like this. Anyway, I'll guide you through it so you at least somewhat understand what's happening. So the output of the adder goes here through the AND gate, and here's the AND gate of a multiplier. Here they join up, and they go into the number display unit. This is the line that selects the adder, and this is the line that selects the multiplier. And then this is the overflow line, because of course the multiplier can also overflow, and that joins up with the other overflow line. And then here you have the register A and register B multiplier. Register A is where it can go up to 7, register B is where it can go up to 3. And those all run into the control panel. So let's give it a shot. Let's do 3 times 5. So that will be 15, and immediately the biggest number the number display unit can represent. So first 0, 5, and write it into register A. Also use wooden buttons to be sure, because wooden buttons are activated longer than stone buttons, giving the calculator or computer more time to react to the input. And then 3, the biggest number register B can handle. Okay, and of course nothing yet, but if we do this, then it should start working, and there we have it, 15. It works. So that will be today's episode. As you see, this was again quite a lot of work. Not as much as the previous one, but quite a lot of work. If you want to see this expanded, uh, comment it in the comments down below. Obviously, comment in the comments. Okay. Anyway, next week it is possible that there is no episodes, no video, or something completely different that you haven't seen on this channel yet, and you don't actually see very often on YouTube. If you, because the next logical step would be to something with a subtractor, but that's quite complicated, and I already spent a lot of time trying to figure it out, but I'm still not there. Anyway, there is one little thing that you could add, but I kind of ran out of time to design it, and that is that you take this output. It's actually not that hard, so I'll just tell it, but I won't build it. You take this output and you run it back to over here. You take this, of course, and you push it all to there with roll at it, so you have a little bit more space, and then you let it join up, and you use one of these. So what you can do is then push the button that will activate this component, and then you write, I mean not that component over there, but you build the same component but on this line, and then you can write the output onto the input so you can use it again. Of course, you could just copy the number like 15 and then do something with it. Of course, 15, that will overflow no matter what I do, except if I add 0, multiply by 0, or multiply by 1. But that's going to be it for today. Thank you so much for watching. If you liked it and if you learned something from it, please consider subscribing. It would really, really, really make my day. I hope you have a good day, and bye!